Here we go. This is the last video of your final exam review, chapter 7, page number 2. So on these, very similar to unit 3 in that we have to take the inverse signs at the end, but before that, we just have to solve an algebra equation. So if you look at this first one here, you said 15 theta minus 9 equals 2, right? So just treat it like any other algebra equation. Instead of like a sine of theta, think of it as 15x. Minus 9 equals 2. All right, how would you solve that? Well, the first thing you do is you add 9 to both sides. You'd have 15x equals 11, then divide the 15 away, and you have x is 11/15. This is going to be no different, but instead of an x, we just have that sine of theta in here. So I'm going to add that 9 to both sides first. And if we just go step by step here, we have 15 sine of theta equals 11. Now just divide that 15 on both sides here, and we end up with the sine of theta equals 11/15. All right, so that part, that's algebra 1 right there. All right, now this is where we get into the trig component. We have to take the inverse sine of both sides because we are trying to solve for theta. So we're going to say the inverse sine, the sine, inverse sine, they cancel out. We're going to be left with theta equals the inverse sine of 11/15. Right? Now, we need to have two answers here. But on this whole unit, this section, we are very reliant on our calculator. We need to make sure we're in the right mode. This one wants us to use degrees, so just make sure you are in degree mode and type this into your calculator. The inverse sine of 11/15. Let's see what that is. That gives us, I'm going to call that 47, right? This is equal to 47. But keep in mind, we have two answers here. We know according to our chart here, the ASTC, we should have two answers. One answer needs to be in quadrant 1, and the other one needs to be in quadrant 2 because that's positive 11/15 here, right? So if we think about this, let me get rid of that real quick, make another graph. The first one, that 47 that the calculator gave us, that is one of our answers. All right, that 47, not only is that a reference angle, but since it's in Q1, that's the answer. The second one needs to be in quadrant 2. So use that reference angle 47. We just have to think we're going backwards, right? It's not exactly 180 degrees. So we have 180 minus 47, and that gives us 100, and I want to say 133. Yeah, all right. So our two answers for this equation, we're going to have theta equals 47 and theta equals 133. All right, so we have two answers on these things. So if we were to plug those back in to this equation, let's just try that one time. We're going to have 15 times the sine of 47 minus 9. This should be pretty close to 2. Keep in mind, I rounded. The answer was 47.2. I called it 47. So it's not going to be exactly 2, but it should be close. And it would be even closer if I typed it into the calculator correctly. It needs to be a minus 9. There we are. So 1.97. The answer is supposed to be 2. That's pretty close. Right? But that's what happens when we round. Right? So that's how we do this section, right? So there's 6 of these problems. So 1 down, 5 to go. Right? So first things first, on this next one, subtract by 15 on both sides. We end up with 2 times the secant of theta equals 9 minus 15 gives us a negative 6. All right, divide away the 2, chop both sides in half. We're going to get the secant of theta equals negative 3. All right, now on this one, keep in mind we have a secant. Secant, again, the reciprocal of secant, that's 1 over sine. So when I do a problem like this, I'm going to call this 1 over the sine of theta. We have to do this because there is no secant, cosecant, cotangent. Those functions aren't on the calculator, so we kind of have to do this part by hand. So you have 1 over, see, I already made a mistake. Secant goes with cosine, not sine. Let me redo that. So it's 1 over cosine, right? So 1 over cosine equals -3. So take the reciprocal of both of those, and you can say the cosine of theta equals -1/3. Right? Now we are ready to take the inverse. Right? So taking the inverse, cosine on both sides. Remember, inverse, cosine, arc, cosine, those mean the same thing. We are going to get theta. Theta equals the inverse cosine of -1/3. And again, that is not a nice number. That's not anything on the unit circle. So we're going to have to punch that into our calculator to see what comes up. So the inverse cosine of -1/3. That gives us, I'm going to call that 109. It's not quite enough to round it to 110, so we're going to keep it 109, right? Now, keep in mind this thing right here, this -1/3, right? It's a negative number. According to this thing, right, cosine is negative in quadrant 2 and in quadrant 3. Let's see here. So the 109-degree angle that they give us is one of the answers. However, we need to use that 109 to help us figure out the reference angle. Right, so this 109-degree angle is right here. Right, we need this reference angle. What is it going to take to get us back to, or get us to 180? That is 81. No, it's not. It's 71. Right, this needs to be a 71, right? 109 plus 71 gets us there. So the reference angle here is a 71-degree angle. I'm going to make a note of that. All right, so theta, second one, we know has to be in quadrant 3. So that's going to be 71 degrees beyond the x-axis. So this is 180 plus 71, right, which is I want to say 251. So our two answers for this problem, theta equals 109 and theta equals 251. So there we have it. And again, we could plug both of those into this problem, and it's going to spit out a 9. Right? So now on to the next one, we have a tangent problem. Not only is it a tangent, but it's a tangent squared. So we have 10 times tangent squared of theta equals 5. Right? Now, divide away the 10, and we're going to have tangent squared of theta equals 1/2. Right? So from here, tangent squared, how do you kill a square? Well, you need to square root both sides, right? And one extra thing, anytime you're solving an equation and you take a square root, you have to put the plus or minus in there, right? So we end up with the tangent of theta equals plus or minus. This ends up being 1 over the square root of 2. But if we rationalize that denominator, we're going to get 2 over, sorry, we're going to get square root of 2 over 2. So that plus or minus literally means plus square root of 2 over 2 or minus square root of 2 over 2. So from here, we have to split this up into two different problems. All right, so we have the square root of 2 over 2. And then over here, we have the negative version. We have negative square root of 2 over 2. All right, so on this problem, anytime you have one of these squared problems, there's a pretty good chance you're going to have 4 answers, right? So over here, we know tangent is positive in quadrants 1 and 3, right? So our 2 answers should be in quadrant 1 and 3. So I'm just going to punch this into the calculator. Let's see what comes up. The inverse tangent, I guess I should write that down. The inverse tangent on both of these let's see what that gives us. It's 35.2. I'm going to call it 35. All right, so if we think about this chart, we have one that is a 35-degree angle. So in this case, that 35 is one of our answers, and it's our reference angle. So we have to use that to help us figure out the other one. All right, so this is 35 degrees beyond 180. So we're going to have 180 plus 35, which is going to give us I want to say 215. All right. So the two answers for the positive version of this one, we have theta equals 35, and we have theta is 215, right? But we still have to look at the negative version of this one, and we know tangent is negative in quadrants 2 and 4. Right, so both of our answers need to be in quadrant 2 and quadrant 4 on this one. So same process as before, take the inverse tangent. And we want to type this into our calculator now. So it's going to be the same thing as this. The only difference is we need that negative in the front. So I'm just going to copy and paste it down. And I'm going to put a negative sign in front. And that gives negative 26, right? Negative 35, rather, sorry. Right? But if we think about that, if we read the original problem, they want us to keep between 0 and 360, right? So if we look at that negative 35, it's not the one we want, right? So yeah, this is a negative 35-degree angle, but that's not the one we're looking for. We need to find the coterminal angle, which is 360 minus 35, which gives us 325. The second one in quadrant 2 has to be 35 less than 180. So this answer is 180 minus 35, which gives us, what does that give us? 150, 145. So the two answers over here are 145 and 325. Right? And again, we have 4 answers for this problem because, and it ended up being that tangent squared. Anytime you have this squared right here, there's a good chance that you're going to have 4 different answers for these. So that's just something we have to be aware of on here. So those were all degree measures. What about if they are radian? Well, it ends up being the same exact process, but we just have decimal answers instead. Because remember, pi is just some big decimal. So the first thing you should do is check your calculator and make sure you are in radian mode. All right. If you're trying to do these in degree mode, it's not going to make any sense. All right. So really check, know what mode you're in here. But otherwise, process is going to be exactly the same. I'm going to skip a couple of steps here. So the tangent of theta equals, if I had the phi, that's an 8. Then I'm going to divide the 17. We have 8/17 here. All right. Then I'm going to take the inverse of both sides. I'm going to try to not make any mistakes. Theta equals the inverse tangent, or again, the arc tangent, whichever one you prefer, with 8/17. Right? We're going to put that into our calculator. The inverse tangent of 8/17. And again, this is some decimal. They tell us to round it. What do they want us to round to? 2 decimals on these things. So that's going to be 0.44. Right? So now on all of these, we have to keep in mind what quadrant we're in. Where is 0.44 radians? Well, remember, we have to think about everything in terms of pi now. So half of a turn, or 180 degrees, we're not going to think of 180 over there. We're going to think of it as 3.14, right? Because that's pi. If you want to figure out that 90-degree angle, that's 3.14 divided by 2, which is 1.57. Right? And then bottom one is 4.71. And then this one over here is 6.28. Right? So that's going to be those those angle measures in radians now. So that kind of helps us divvy up what quadrants we need to be in. All right, so 0.44 is between 0 and 1.57. So not only is this the reference angle, but it's also an answer here. All right, so that is one answer. We know tangent is positive in quadrant 3. So our second answer needs to be down in quadrant 3. So that is going to be 0.44 more than pi. Right? So this needs to be 3.14 plus 0.44, which gives us 3.58. Right? So the two answers for this problem, we have theta equals 0.44 and 3.58. Right? And again, if we wanted to confirm either one of those, plug them back into your calculator, right? This is no different than how we would check it in Algebra 1. So I'm going to say the 17 times the tangent of 0.44 minus 5. This should be pretty close to 3, right? And it is, right? We could do that with the other one. So I'm going to plug in, so we have 17 times the tangent of 3.58. Right? Subtract 5, and again, that should be close to 3, which very, very close. Right? Right, we round it a little bit. We round to the nearest hundredth. That's why our answers differ in the hundredths place. Right? Oh man! All right, on this next one here, this looks like we have some factoring involved. So let's see here. I know it's going to be a factoring problem because we have a sine squared, we have a sine, and then we just have a number, right? So 1 times 1 is 1, so we know it has to be 1 in that second spot. I'm going to put a 3 sine in the first one, 3 sine of theta, and then I'm going to put a 4 sine of theta in the first one, all right? Because 3 sine of theta times 4 sine of theta gives us that 12 sine squared of theta. When we add these two things together, we need to get a -4. So just by looking at that, I know these are the wrong answers. So let's try something different. Right? I'm going to try 6 sine of theta and 2 sine of theta. I'm going to make one of these a positive, and I'm going to make one of these a negative. Right? So we have to kind of think about our factoring here. If we multiply these two together, that's -2 sine, and if we multiply the outside ones together, that's a +6 sine. right? 6 minus 2 gives us that 4 there, but that would be a positive, so that tells me our signs are switched. So I need to make this one a positive, and I need to make this one a negative. And when I do that, that's going to switch these signs, and that'll get us that -4 sign that we're looking for. All right, so this is the correct factoring of this quadratic, and now we're ready to move on. So again, we have that sign squared in there. Anytime you have that sign squared, it's going to be 4 answers. So we take each one of these factors and we set them equal to 0. So 6 times the sine of theta plus 1 equals 0. That's the first one. And the other one is 2 times the sine of theta minus 1 equals 0. All right, so take each one, solve them. All right, so the first one, you're going to have the sine of theta equals -1/6. All right, so I'm going to inverse both sides there, and we're going to have theta, or I'll write this, yeah, theta equals the inverse sine of -1/6. All right, that's a negative fraction. So where's that going to be as far as our quadrants go? Sine is negative in the bottom two. So it's going to be negative in quadrant 3 and quadrant 4. Right, so the inverse sine of -1/6, what does that give us? -1.7. All right, so if we look at that one, we are at -0.17. All right, that is our reference angle here. So I'm going to go ahead and just throw one on this side as well before we do any math here. That's 0.17. In fact, I'm going to get rid of that negative sign there. All right. So we need it between 0 and 2 pi. So those reference angles, we're going to have to add and subtract stuff. So the first one, that green one, that is 0.17 radians beyond pi. So I'm going to add 3.14 to that. And that gives us 3.31. And then the second one, that is 0.17 less than 2 pi. So we're going to take 6.28 and subtract 0.17 from it. And that is going to give us 6.11. All right, so the two answers for this first one, we're going to have theta equals 3.31 and 6.11. And so there's two answers. But keep in mind, this was a squared problem, and we have this other one over here, the other factor that we have to take into consideration. So just doing some quick math here, we're going to get sine of theta equals 1/2. Right. But if you notice this one, sine of theta equals 1/2. This is actually a nice one because this number, 1/2, is on the unit circle. Right, so we don't really have to punch anything into the calculator on this problem. Right, just find where is sine of theta equal to 1/2 on our unit circle. Those are going to be in the top two quadrants. That is at pi over 6 and 5 pi over 6. And that one's done. So those second answers worked out pretty nicely. All right, so kind of pay attention to those important numbers. That can make these things go much faster if we recognize their unit circle problems. If you don't recognize that, that's okay. It's just going to take you a little bit longer. All right, so on this last problem, here we go. Subtract the 10, divide by 3. So you're going to have 27 divided by 3. All right, so the cosecant here, that gives us -9. All right, again, it's cosecant. We need the reciprocal of that. So this is 1 over the sine. 1 over sine of theta equals -9. Flip them both upside down. The sine of theta equals 1/9. I'm going to take the negative, I'm going to keep it on top. All right. So from here, take the inverse, we're going to have theta equals the inverse sine of -1/9. No idea what that is. So let's plug it in. And again, these are radians, so it's -0.11. Right, so that gives us a reference angle of 0.11. And again, it's a negative value. We know sine is negative in quadrants 3 and quadrants 4. Right? So the two angles we want are the blue one and the orange one. All right, so that red one, that's 0.11 beyond pi. So we have to add pi to that number. Right, so the first answer here is going to be 3.25. And the second answer is going to be 2 pi minus 0.11 because we're not quite to 2 pi yet. So we're going to have 6.28 minus 0.11, and that gives us 6.17. Right, so the answer in the final two answers of this class, 3.25 and 6.17. And there we have it. That is unit, what unit is this? Unit 7. That was unit 7 in its entirety. And there you go. That's going to be the last video here. So good luck on your guys' final.